All right, question number 3. Now we're going to start putting these things together. So in our new equation here, our original equation was f of x. In our new equation, can you see that you have a 4 multiplied outside of the function and a negative 0.5 multiplied inside the function? So if we were going to describe these things, first of all, the 4, that would be a vertical stretch by a factor of 4, semicolon. That's what the 4 would do. What's the negative going to do? If the negative affects an x value, think about an x value getting negative. Can you see that that would go over the y-axis? So that negative would be a reflection over the y-axis. And then the 0.5, that's a fraction of a half. The reciprocal of a half is 2. So that 0.5 is going to be a horizontal stretch by a factor of 2. Now that's writing it out in words. As far as the shortcut, what are we going to do? We're going to take our y coordinates and multiply them by 4, and our x coordinates and multiply them by negative 2. So when we're looking at the graph that we have, and we are given this graph, obviously the most important point is going to be the starting point at negative 2, 0. Can you see any other points? Looks like we have point here, negative 1, 1, and we have a nice point there, 2, comma 2. So when you're showing your work and you're taking specific points, we have those points from our original graph, above the arrows, tell me what you're doing so that I can see if you've made a mistake, I can see what that mistake is. And above that is just what we've written in the green here. What are we going to do to these points? We're going to multiply our y's by 4 and our x's by negative 2. Yes? Because with the x value, again, remember, whatever is in here, it's going to be the reciprocal of that. So the negative is going to flip it over. That multiplies the x by negative 1. And then the 0.5 is actually 1 over 0.5. Or if you think of 0.5 as a half, the reciprocal is 2 over 1. And so we need to multiply that by 2. Again, what happens inside always appears to be the opposite. Left and right get mixed up, and instead of a half being a compression, it's a stretch. Now that we've got those there, we can say, well, what happens if I multiply negative 2 by negative 2? I'm going to get positive 4. 0 by 4 is still 0. Negative 1 by negative 2 will be positive 2, comma 4. And negative 4, comma 8. So we can put those new points on our graph. We have 4, comma 0, 2, comma 4, and negative 4, comma 8, which I guess would be way up over there. The other key thing to notice is that this was our starting point, right here. So this will be the starting point of our graph after we've changed it. That's important because we've drawn 3 dots. You might decide to connect them the other way and have the arrowhead go in the wrong direction. But if I know that this point is my starting point, then I know my graph has to go up over in this direction. State the domain and range of each of these functions. I used set notation last time. I'm going to use interval notation this time. So the domain, well, the smallest value of our original graph was -2, and that value was included, and then it went on forever. So we'd say -2 to infinity. Our range, our smallest value, is 0, and it went up forever. So we'd say 0 to infinity. Now, if you think of your transformations, what's happened to your x values? Your x values have been multiplied by a -2. So if I multiply -2 by -2, I'm going to get 4. What happens when I multiply infinity by -2? You get negative infinity. So if we look at our graph, can you see that we now in the blue graph have no smallest x value because it goes on forever to the left. So it would start at negative infinity and it goes up to 4, and 4 is included. For your range, do you have a smallest value? Well, what happened to our y values? Our y values got multiplied by 4. What happens when you multiply 0 by 4? Still get 0. What happens when you multiply infinity by 4? You still get positive infinity. So our range didn't change. I'm going to add a part B and a part C to this. So part B. What is the explicit equation? And an explicit equation is in terms of x. So again, I'm trying to introduce or reintroduce language for you guys. What is an explicit equation in terms of x of y equals f of x? What is the actual equation of that red graph? What kind of graph is it? Square root. But it's been moved, right? How has it been moved? To the left. How do we write that? Square root of x plus 2. Good. And now, part C, what is the explicit equation, again, in terms of x of y equals 4 f of negative 0.5 x. So, something to think about. Well, instead of f of x, we wrote this as y equals the square root of x plus 2. In other words, we are saying that f of x is equal to the square root of x plus 2. If that's the case, how do we work with this function notation? What does this mean? Y equals 4f of negative 0.5 x. Well, it means there's going to be a 4 multiplied by this. And f of negative 0.5x, what function notation means, is whatever you put into that function, So if I put in 0.5 inside of that function, that's going to be instead of this. So that replaces everywhere where there's an x. So in my original function, I had the square root of x plus 2. This part right here is now going to be the square root of, and instead of x, I'll have negative 0.5x plus 2. And this 4 will still be multiplied out in front. And so that would be the explicit equation of the blue graph that we just graphed. Okay, now I'm going to give you some time to work on those questions from this set of 3 and ask questions if you have some, either from this example or your homework examples.